Okay, let's talk about the scientific method. Scientists use scientific method to solve problems all the time, whether you're in a science class or just sitting around your house. You use these kinds of processes to solve problems all the time. First, you have to have a problem. You have to know what's going on. That requires you to open up your eyes, look around, and do a little observation. Figure out what the problem is. Then you form a hypothesis. What could be causing your problem? Then you test it. You figure out some kind of experiment to collect observations and data and see if you're right. This is what's causing my problem. Now, these are the three that we do most of the time in our class. We don't typically get to the next two. We don't necessarily get to the theory stage because this is high school. But if you were to go on, you could take your hypothesis and develop a theory, which is a broad generalization that happens to fit most of the facts. That doesn't explain all of them, but explains most of them. And then, if your theory proves to be correct all the time with no exceptions, you develop it into a scientific law. There are no exceptions to the law of gravity. Nobody ever jumps up and stays up. Always come back down. It always works. And this is just simple logical problem solving. We do it all the time in all areas of life. So, for example, I have a real life problem. This actually happened to me. I went to Walmart, and this is the Walmart in Yuma that I go to, just to get some stuff. We ran out of something for dinner. My wife didn't want to go because she wasn't feeling good, so I went. And I get my stuff, and I come back out, and I have a problem. My car won't start. Well, it's July in Yuma, and it's 100, and who cares? This is a problem. So, I develop a hypothesis. Maybe I've got no gas. Maybe I've got a dead battery. Maybe I've got the wrong key in it. Back in the day, you had two keys for a car, one for the doors and one for the ignition. Maybe I've got the wrong car, but that one really didn't make any sense. So once I come up with some ideas, I start testing them. I check the gas. I got plenty of gas. I turn on the headlights so I know that the battery's not dead. There happened to be only one key for this car, so I'm thinking either I've got something majorly wrong with this car or I'm in the wrong car. And I'm beating my head against the steering wheel because it's pretty hot. And this guy gets into the white van next to me, backs up, and I look over to the left, and there's another Pontiac Grand Am just like mine, the exact same color and everything, only that one had my wife's little Jeff Gordon air freshener hanging from the rear view mirror. So this whole time, I was in the wrong car. I kind of peeled away from Walmart at that point after I got into the right car and moved on with my life. Now, science is all about measurement. Qualitative measurements, these are measurements based on something other than numbers. Things like color and odor, or whether or not something feels hot or cold. For example, whenever you wake up in the morning and tell your mom you don't feel good, she reaches up, first thing she does typically is test your forehead, touch your forehead, and see if you feel warm. That's a qualitative measurement. No mom has ever reached up and said, yes, you have 102.5 fever with her hand. If she can, that's a neat trick. Quantitative measurements are measurements that are based on numbers, things like temperature, for example. This is what happens afterward. Once you feel warm, mom grabs a thermometer, sticks that in your mouth, and says, hey, you've got 102.6 temperature. Maybe we should get you to see a doctor. So qualitative and quantitative. Typically, you want to be good at both. You want to be able to describe it and to measure it, whatever it is you're doing. Now, good measurements are going to be both correct and reproducible. You get the right answer more than once. Accuracy is how close your measurement is to the accepted or true value. So if I measure my computer screen here at 14 inches across, but the manufacturer says it's 14.25, that's a pretty accurate measurement. I'm off by 1/4 of an inch. That's not too much. Pretty close to the real value. Precision, however, is how close a series of measurements are to each other. This is getting the same answer more than once. And I don't really care about the right answer. I want to make sure that my measurements are getting the same answer every time. So if for whatever reason I decided to measure the length of a football field 3 times and I get 100 yards, 92 yards, and 113 yards, these are not precise because they are nowhere near each other. There's a huge gap between these 3 measurements. Ideally, I want to get the right answer, and I want to get the right answer more than once. Okay? So good measurements, correct and reproducible, and they should be both qualitative and quantitative.